Welcome to The Explainer. Today we're going to unpack the story behind Vikram, which is India's very first fully homegrown semiconductor chip.
So, why is a single tiny piece of silicon basically a national event? Let's dive right in. We're going to explore why the launch of this one chip is making such big headlines and what it really signals for tech, for self-reliance, and, the whole global balance of power.
All right, so here's our game plan. We'll kick things off with the big reveal. Then we'll pull back to look at the national strategy that made this all happen. We're going to get to know the Vikram chip itself, really unpack why it's such a game changer. And then, to wrap it all up, we'll see where India fits into this high-stakes global chip race.
Okay, first up, let's talk about the event itself. Not long ago, India's IT minister presented Prime Minister Modi with the Vikram microprocessor. Now, this was way more than just a photo op. This was a huge symbolic moment, the launch of the nation's very first completely homegrown chip, a real, tangible symbol of its made-in-India dream.
And they didn't do this in a back room somewhere. Nope, this reveal happened on a global stage right in front of industry leaders and big-time investors. So yeah, this wasn't some quiet little product launch. It was a loud and clear statement of intent about where India sees its technological future.
But here's the thing, a chip like this, it doesn't just appear out of thin air, right? It's the direct result of a really carefully planned, long-term national strategy. After those massive supply chain shocks we all felt post-COVID, India had a big realization. It just couldn't afford to be so dependent on other countries. So back in 2021, it launched the India Semiconductor Mission, and they backed it with a huge initial investment, all with one massive goal, to become a global semiconductor hub. So how are they doing it? Well, the whole strategy is built on three key pillars. First, you've got to build the incredibly complex manufacturing facilities, the fabs, from the ground up. Second, you need to nurture a local design ecosystem. Get homegrown startups creating their own chips. And third, and this is crucial, you have to develop the top-tier talent needed to power this whole thing.
Okay, so let's zoom back in from that big national strategy to the star of our show today, the Vikram 3201 microprocessor itself. What is this thing, really?
Well, first off, its name is this incredible tribute. It's named after Dr. Vikram Sarabhai, who was basically the father of India's space program. And that's so fitting, because the final frontier, well, that's exactly where this chip is designed to go.
All right, let's pop the hood and see what's inside. It was designed by none other than the Indian Space Research Organization, ISRO, and actually built in a government lab. At its core, it's a 32-bit chip. But its real superpower is its toughness. This thing is officially certified as space grade, which means it's built to survive the absolutely brutal conditions of a rocket launch and the harsh, unforgiving vacuum of space.
Now, you might see that it's a 180 nanometer chip and think, wait a second, my phone is a tiny 3 nanometer chip. Isn't 180 nanometer kinda old technology? And for a phone, you'd be totally right, but not for a rocket. See, in space, you don't need the smallest, fastest chip. You need the toughest, most reliable one. This larger size actually makes it incredibly durable and resistant to all that cosmic radiation up there, which is exactly what you want when a multi-million-dollar mission is on the line.
Okay, so beyond all the cool tech specs, why does this one little chip matter so much? Well, because its creation has these massive strategic implications that go way, way beyond just a piece of silicon.
Get this. Every single year, India spends a staggering $25 to $30 billion importing foreign chips for literally everything. Phones, cars, you name it. That level of dependency, that's a huge strategic vulnerability. And Vikram, well, it represents the very first step in trying to solve that problem.
So, Vikram's true importance, it really boils down to three big things. First, self-reliance. This is huge. India's critical space and defense programs are no longer held hostage by foreign suppliers. Second, it kickstarts the entire domestic ecosystem. It proves India can handle the whole shebang, design, fabrication, testing, all of it. And third, it's a powerful benchmark. It sends a message to global investors that says, hey, India is a serious player now.
But listen, Vikram is just a starting gun. This is only the beginning. So let's take a look at the roadmap and see how this one single achievement fits into a much, much larger national plan. And the momentum is already building big time.
Right now, 5 new manufacturing plants, we call them fabs, are under construction. Over 30 different chip design startups are getting government funding to innovate. And, get this, a successor to Vikram, a more powerful 64-bit version called the Kalpana series, is already in the works. The long-term goal here is to methodically shrink these chip sizes down to compete in the commercial market too.
All right, for our last section, let's zoom out one final time. Because honestly, you can't talk about semiconductors today without talking about the intense global competition for chip supremacy. It's a huge deal. So the big question is, where does India's progress fit into all this?
Look, we're smack in the middle of what people are calling a geopolitical chip war, with the US and China as the two main heavyweights. In this incredibly high-stakes environment, India is strategically carving out a role for itself. It's not trying to be a direct challenger, not yet anyway. Instead, it's positioning itself as a new, reliable, and potentially vital partner on the world stage.
This really breaks down the global chessboard perfectly. You've got the US, which absolutely dominates advanced design with giants like NVIDIA and Intel. Then you have China, leveraging massive state support to build its own self-reliant ecosystem. And India's key strength? What's its ace in the hole? An absolutely incredible pool of design talent. Think about this. Indian engineers already make up 20% of the entire world's semiconductor design workforce. The mission now is to bring that talent and our work back home.
So while India definitely has a long road ahead to catch up with the industry leaders, the Vikram chip is definitive proof of a fundamental shift. The nation is no longer just watching from the sidelines. It has officially and finally entered the race.
And this leaves us with one final thought to chew on. We just saw why a bigger, more robust chip was the right call for space. But for pretty much every other application on Earth, the race is to get smaller and smaller and smaller. So as India and the rest of the world push from 180 nanometers down to 65 nanometers, and all the way to 5 nanometers or even 3 nanometers, what's the ultimate prize they're all chasing? What's the real fundamental advantage of getting smaller?